at Walmart, and co-speaker Subramanya Mogan, tech lead at Walmart, who will be speaking about self-service metadata configuration-driven data load and computational platform. And for this one, if we would like to extend the Q&A a little bit. Okay.
Good morning, everyone. Am I audible? So thanks for joining this session today. I'm going to talk about self-service metadata-driven data loader framework. Before we get into the topic, let me introduce myself. My name is Manimuthu Ayyannan. I'm a senior engineering manager of personalization at Walmart Global Tech, currently leading some of the key initiatives under data platform services. And in our today's topic, I'm going to cover some of the key highlights about our presentation. These will be my agenda today. And so first we are going to see how personalization data landscape working at Walmart, what are the different challenges that we faced, and the different challenge solution approaches we implemented to overcome those challenges. And further, we can take it deep dive on the high-level system architecture and also some of the underlying key components like metadata design, connectors, orchestrators, schedule optimizer, and telemetry. Okay, personalization at Walmart. Why personalization? So personalization is one of the key components to understand the customer and serve them better. So at Walmart nowadays, customers are everywhere. They go to in-store, use mobile app, or visit website to purchase the product that they need, and they are becoming increasingly omnichannel. So if you look at the statistics, approximately 220 million customers and members visiting thousands of stores and clubs under different banners in different countries and e-commerce website in a week. And because of this, we are seeing serving billions of product impressions to our customers in a week. So that generates huge volume of data in petabytes. So we at future engineering team at personalization, we run thousands of applications to read and consume this huge volume of data coming from the different entities of Walmart, the Walmart groceries, Walmart general merchandise, Walmart store. So we consume all these events and process it and generate a meaningful feature out of it and store it in our feature store. And our data science models are leveraging these features to generate a personalized recommendation to our customers. So personalization data landscape at Walmart, it's a pretty standard one, where we have different personas like data engineers, data scientists, and data analysts, where they build the different data applications and deploy it to production by leveraging the different data stores like streaming, in-memory, NoSQL, and analytical. And these data stores are powered by different Walmart multi-data centers and public cloud. Let's talk about some of the challenges that we faced. Onboarding any new application is cumbersome, right? So it takes a lot of manual effort, and also it takes a lot of effort for developer to create the different components that they needed to integrate with the different source and things, and also they have to integrate with the different big data technologies, and also they have to develop a data process for each and every applications to solve the underlying complexity of their requirements. So, and also the second one is it's very difficult to control the resource allocated to their applications and do the retrospection. For example, whatever the resource allocated to my data application is completely leveraged effectively and or how well is my application is performing. Is something has to be monitored over the period of time, and the lastly is something that when I run my high priority and low priority applications and trying to complete and write to the same data center, same data store at the same time. So there are some latency has been introduced to our serving layers. This is something has to be handled in a smarter way. And then if you look at this slide, this is the typical onboarding flow of any new application onboarding in data applications. For example, developer has to integrate with the different source and target systems, and develop a processor to execute the business logic, and implement a security logic and a security protocol in place to handle the personal information, personal identity information, and enable the telemetry to get alerting and notification about your application progress, and finally allocate some resource to your applications to test it and deploy it into your production. And it's pretty much repetitive and redundant across the new applications. So every time user has to follow the same repetitive process to create and deploy their application to the production. And our data loader platform simplifies the entire onboarding process. So where we have created abstract layer on top of these different services, we created the different integrations and provided an standard processors, standard connectors, standard parsers, where data developer they can go and pick up the required components and build their orchestration flow and deploy it to production. So developer has to only worry about how the business logic is implemented through our configurations, and only configure it into our deployment production platform and deploy it to production. And these are some of the solution approach we considered during the implementations. We wanted to have some sort of self-service, centralized metadata system with some plug-and-play capability, onboarding capability, where user simply goes to the platform, build the orchestration flow by choosing the readily available connectors and parsers. So with that, they don't have to worry about solving the underlying complexity and integrating with different services. So with that, we also wanted to have some intelligence system to provide optimized recommendation for reading through passing through the different execution logs and provide the optimized recommendation for our resource allocations. And lastly, we also wanted to have some smart run schedule code, so which kind of prioritize and deprioritize the application run instances based on the criticality of the applications. So by considering all these solution approach, we came up with high-level system architecture. This is our overall architecture, where user can log into this platform, where they can see the user dashboard with all the pre-built applications and currently running applications on the production, and user can create the new applications by choosing the different data services. So when I say data services, so there may be a scenario that the user wanted to consume the data from Kafka to GCP, and that may be a one data service, and loading the data from GCP to Cassandra or some other data store can be another data service. So where user can build the orchestration flow based on the requirement, and deploy that, create the application and deploy it to the platform. So once they build the orchestration flow, the same metadata component will be recorded into our metadata store, and also user can do the test and dry run. So in order to validate the data quality check and everything, user can simply trigger an ad hoc run, so which will trigger the workflow execution in our stage environment. So the workflow execution, this will take care of executing your stage application. This will call the orchestrator to execute your application. So orchestrator is something that is responsible for building the optimized execution plan for your application, and it will ask the executors to execute the plan that they generated. and it will return the status to the core engine. So that will return the status to the user dashboard. And then once the user is comfortable with the data testing, and they can go through the release process, and they can go through release the application to production through our deployment lifecycle, where we have implemented our automatic CI/CD and version control process, which takes care of moving all the metadata components to production environment, and also dependent jars and metadata system to production environment. So we have what another component which is a resource optimizer. So like I said, this resource optimizer is kind of like based on the previous run history. It passed through the logs and then come up with the optimized recommendation for effectively using your resources in future runs. And then this will be our metadata under the hood that is powering the architectures. If you look at, we have different table schema. The app info is the one that where we have different important key attributes about the applications, like app priority and app core group and app and some other app related information. And the app loader service is another key important table where it has like app loader service related information. So like I said, app loader is something that consuming the data from Kafka to GCP is one app loader service, and loading the data from GCP to Cassandra is another data loader service. So one application can have a number of data loader service associated with. So, and if you look at the app loader service, this will have all the attributes like what will be your source logic, how is your target table data looks like, what will be your target write approach, whether it's write and append, or what will be your loader type, is it incremental or snapshot or HT data load. So it kind of records all the configuration about the data loader service, and based on that we have different supporting dimension tables like app user, app core group, app domain, and also we do have the app run schedule and run status, which will record the application run schedule and also the run status of the different runs. And let's talk about some of the key components powering this architecture. So connector is one of the key component. So this one is something that connector is responsible for providing the various parser to different data formats. For example, we have a parsers implemented for standard data formats like JSON, Arrow, Parquet, and CSV, and also it comes up with a standard integration with different system connectivity like Syncs connectivity like Kafka, Cassandra, and EQ, and also we have a metadata store that records the resource allocation configurations, which will be used by our resource optimizer to provide the optimized recommendations for the currently running production applications. And the most importantly, like we have abstract layer on top of the different system like Kafka. We've opened up SQL like features where they can simply run the SQL query on top of these systems and come up with the business logic. And here, this layer comes up with a bundle of different user-defined functions, custom user-defined function. For example, if I want to read the key value from the JSON payload, I simply create a user-defined function on top of it and expose to our abstract layer. Similarly, we have bunch of frequently used user-defined functions available on these abstract layers. And this is one of the example for integrating the domain API call in our SQL UDF. For example, accessing any API service in our data pipeline is challenging. It requires a lot of effort in integrating that API service in our pipeline. Making the authentication authorization protocol in place, and sending, creating the secure client and making the request to get the response from the API servers. This is something that complex process like for every new data application integration, it requires a lot of manual hand coding to connect with these servers. So what we have done is like we took all the functionality and wrapped it with the user-defined function on top of it, and we deployed it into our platform. So, for example, account status is one of the API that where we can check the account status of any customer. So where what we have done is like we created a user-defined function, SQL user-defined function on top of it, and we opened it in the platform, where user can simply write a simple select SQL, like get account status and just pass the customer ID, and then fetch the status of that customer from the API server directly. So they don't have to worry about understanding the underlying complexity by integrating with the various API integrations. And then we have our orchestrator. So orchestrator, like I said, is the responsible for building the optimized plan for executing any applications. For example, I have a monthly job which is running for 8 hours, which has like thousands of partitions, and our orchestrator will go and read the configurations and try to come up with the optimized plan. For example, rather than letting the complete monthly jobs at one go, it will come up with a plan like splitting into some multiple subsequences, like multiple chunks. So there will be 20 instances, like for example, 20 new instances will be created for the particular applications, which will be passed to our app scheduler tool. And this plan will be picked up by the executors during the execution of any application. And then we have a schedule optimizer. So like I said, during the onboarding of any application, so we assign priority group to that application in order to understand the criticality of the applications. So priority group in the sense like core SLA jobs will have more priority than non-core non-SLA jobs, so low priority jobs. So we assign this group intelligently during the onboarding. So based on that, so top priority job instances take more precedence compared to low priority applications at any point in time. So, and also like this will automatically resumes it, like low priority applications are resuming after completing the high priority applications. So this is the illustration of schedule optimizer. For example, we have a current schedule pool at 10 o'clock. We have non-core applications are scheduled to run at 10 o'clock, and there are 6 instances, out of which 2 are completed and 2 of them in progress. And at 10:30, we have a incoming schedule pool 10:30 with the core application instance. So which will be kind of like high priority applications when compared to currently running non-core applications. So our schedule optimizer will enqueue the core application instance in between and put the non-core applications in the background. So this way, so we don't have to worry about missing the SLAs, and also like I said, there was a latency issue introduced to our serving layer when competing the core and non-core applications, trying to write the same data store at the same time. And then lastly, we have a telemetry system. So we have a real-time dashboard that reads the signal from the application execution at different stages of your application execution, and provides the statistics about your applications, so that user can monitor the application during the app execution, how well is your application is performing, and also there is a way to application owner to set the alerting and notification about the application, and also they can set the different alerts based on the data trend, data quality, and job failure as well. And also this telemetry dashboard provides the consolidated view of all the applications. This is mainly useful for the program managers when they want to track of any specific initiative, and they can simply go to this dashboard and see the overall progress of the particular initiative applications and whether are they meeting the SLA, so they can do all the monitoring on top of these dashboards. And then putting the pieces together. So these are the core feature of our platform. So it's completely self-service with plug-and-play capability. So where user can kind of pick the data loader services needed for the requirement based on the requirement and build the orchestration flow to deploy it to production. And each configuration is being recorded in our metadata store, and this will kind of help us to achieve the low code and no code environment. And also currently we have a different execution engines like Spark, BQ, and we are also thinking to expand it to different execution engines as well. So we have a automated version control and CI/CD. So whenever the user makes the changes to any of the existing application, this will automatically takes care of taking the version changes and also deploying the changes to production continuously. And this platform is capable of maintaining the end-to-end life cycle of your data applications, and also it's most importantly cloud native. It comes up with various data sources and things, and lastly it provides the telemetry for the monitoring of your applications. As an outcome of this platform, we could see like there are quite quick turnaround time in onboarding any new applications that comes down from few months to few weeks, and also we are seeing like developer productivity has been increased by multiple folds, and also most importantly, non-engineering team also can leverage this platform to build the functionality-rich applications. All they have to know is like simple SQL, and since we are providing the different connectors, parsers, and data loader services, where they can simply use the SQL like a logic to access these connectors and build the application and deploy it to production. And also the intelligent app execution is something that which provides the intelligent way of scheduling your application run instances and based on the priority of your applications. So it gives more priority based on your application criticality. So that helps us to achieve the SLA on time. And yeah, that's pretty much about the platform. Any questions? I didn't hear that. What was that?
The system, do you integrate customer data with also the backend merchandise manufacturer's data?
Yes, this system is capable of accessing all the data source, like we have data coming from GCP, we have data coming from the streaming real-time data coming from Kafka. So it has all the integrations, all the platform will take care of all the integration effort. So the developer, data engineer, all they have to do is come up with the business logic and plug it in our platform.
Do you use some AI technology in terms of?
So this is mainly for this platform is mainly meant for feature store. So we have a different feature store that has been leveraged by our data scientists. So we are powering the data pipeline for feature store. So it doesn't have any AI capability.
How about online, offline? Is the store data with the online website data also integrated or they are separated?
So I think with the new Walmart integration, we have all the data coming in one place. So we have in-store data coming in, website data coming into our warehouse.
Okay, thank you.
So I kind of have a related question to that. I was just wondering, so based on the online versus in person, when it comes time to do some sort of like if you're trying to optimize something, like using machine learning, would you differentiate those two?
So, kind of like the personalized recommendation is only for online customers who are visiting, Walmart website or mobile app. So, kind of like we read the events from all these in-store. Like if you are using the, same credit card and then going to use it at Walmart in-store, or use the same, like once you log into your account or website and do the transactions and browse through some product. So these are the signals, like we combine and do the, process it combinedly and come up with, meaningful features out of it. So these features are powering the personalized recommendation when you go to, website or mobile app.
Thank you.
Thank you for going through your presentation. Is there, for Walmart, is there an underlying data strategy? And if there is a data strategy, where does this platform sit within that data strategy? And then, are critical applications running on this, or is it only a subset of some of the applications running on this platform?
Okay, so this platform is only developed for, specific to personalization organization. So kind of like there are multiple data platform out there in Walmart, so solving the different use cases. But we developed this platform only for personalization data, where we consume relative information from the respective data source, and also like this has like critical application and non-core application. So we are solving mainly like near real-time application and batch application. So we are not targeting the actual real-time application. So it's more of like powering the models, like by serving the features in place. So for example, when you go to Walmart site, so these features will be available in the serving layer when these features are accessed by our data science models to provide the personalized recommendation to you.
Does anyone else have any questions?
Yeah, thank you.